A student use a meter rule or a meter scale to measure the length x and use the micrometer to measure the width w of a band. And she determined the volume of a rubber band by using a formula 2xwt. Say two reasons why the calculated volume may not be accurate. So what could be the reason as a student use this formula and the calculated volume may not be accurate here? If you see the original question, this is x, the total length, t is the thickness, and w is the cross-sectional area, width. So two reasons why the results may not be accurate. So if you see the figure, x is this part of the rubber band is missing. Like we, it's not like the rubber, the two-fold, it's a two-fold rubber band, not two rubber bands. If it was like this and we measure the x, that is fine. And we just multiply by 2. But if you see this part, we did not include. Like this is also a length which is not included in our result. Like this length is not included. So that is one of the reason why the volume which is calculated may not be accurate. And the second is the rubber band. When the rubber band is there, the as it is the W, like we consider it has a rectangular cross-sectional area, but that rectangular cross-sectional area of the rubber band may not be constant. Why? Because if I stretch a rubber band, then what will happen to the cross-sectional area? The cross-sectional area will decrease. So the two reasons why it will not be accurate, that the for the like for measuring a length of a rubber band, we did not take the folds at the end in our calculation. That is one of the reason. And the second, the width could be measured when the rubber band is compressed as well, like because here the rubber band is stretched between the two ends. So the width, won't the area increase if we stretch? No, no, no. For a rubber band, when you pull a rubber band, its length increases, so the area will decrease because the volume is constant. Volume is area multiplied by length. So if you stretch a rubber band, the area will decrease. If you compress a rubber band, if you reduce the length, then the area will increase. Volume is constant. So the two reasons why it is not accurate, one is we did not take the sides of the rubber band when it is stretched into our account. And the second thing is the width may not be constant when the rubber band is stretched or compressed. That's why this will lead to a wrong result. The next is student made a measurement on a rubber bung. As you can see, the average cross-sectional area of a bung is given by a formula A is equals to pi over 12 d square plus capital D square plus small d square plus d in product of a capital D and small d. Show that the uncertainty in d square is about 0.7. 0.07. The measured value of a d is this, and this one is the uncertainty in the measurement of a d. What we have to do, we have to show that the uncertainty in the d square. So first what we do, we will find the percentage uncertainty. What is the percentage uncertainty in d square? Like if I say percentage uncertainty in x will be the uncertainty divided by value recorded into 100. That is the formula. But if I need a percentage uncertainty in x square, so the uncertainty will be multiplied by 2 divided by value recorded into 100. So if you use the percentage uncertainty, so 2 multiplied by because first what we are doing, first what you can do, you can determine the percentage uncertainty in d, and in d square it will be double. Like if a percentage uncertainty in d will be the uncertainty which is 0.01, No, no, no. It's not done like this. This is not the way for uncertainty. This is not the way like if a percentage uncertainty in x is 2, then the percentage uncertainty in x square will be 2 multiplied by 2. Percentage uncertainty in x cube is 2 multiplied by 3. Percentage uncertainty in x4 is 2 multiplied by 4. That's the method of percentage uncertainty. It's not squared. It's multiplied by that same factor. So for yeah, for it can be done multiple ways. So first I determine the percentage uncertainty in D. Percentage uncertainty in D is the uncertainty which is 0.01 divided by the value of a D which is 3.45 into 100. What is the percentage uncertainty in D? How much is this? 0.01 divided by 3.45 into 100. So it will be actually 1 divided by 3.45. What's the answer here? It's written here in the question. If you read, it's written 0.01. The value which we recorded is this. This is a value recorded and this is the uncertainty in D. First, we work out the percentage uncertainty. So in D, which is 0.289%. Then what about the percentage uncertainty in D square? So the percentage uncertainty in D square will be twice the percentage uncertainty in D. So 2 multiplied by 0.285. What is the answer? 2 multiplied by 0.285. How much is this? 0.579. So 0.579% is the uncertainty in D. Okay. Now we have to show like this a percentage uncertainty in D. Now we have the formula that the percentage uncertainty in D square will be the uncertainty in D divided by value recorded into 100. So percentage uncertainty in D square is 0.579. The uncertainty in D we don't know. What about the value recorded? If D is 3.45, then this will be 3.45 square because that will be D square into 100. Now simplify. So 0.579 times 3.45 square divided by 100. That will give us the uncertainty. Is it clear? 0.069. So we got 0.069, which is about 0.07 centimeters square. That is the uncertainty in the value for D. Is it clear? This part? Why I'd square again? If you see, I have the percentage uncertainty in the D square is the uncertainty in D divided by value recorded into 100. So the uncertainty, it was 0.579. The percentage value record uncertainty, we don't know. Value recorded, it's a D square. So if the value of the D is 3.45, so what is the value of a D square? It will be 3.45 square. Because like D square value will be a square of D. That's why. Is it clear? The next is show that but you said uncertainty formula should be times who. Why didn't we multiply the look, you're confused with the concept of percentage uncertainty. The formula for percentage uncertainty is the uncertainty divided by value recorded into 100. Okay. First, we wrote the percentage uncertainty formula for D. So percentage uncertainty for D is the uncertainty of a D, which is 0.01 divided by the value recorded, which is 3.45 into 100. That is the percentage uncertainty in D, which we were getting 0.0285, I think. That was a that is the percentage uncertainty in D. Now we use the same formula that the percent. And what about the percentage uncertainty in D square? So percentage uncertainty in D square will be twice the percentage uncertainty of D because it's a square there. So that's why it was 2 multiplied by 0.0285, which makes 0.057%. That is a percentage uncertainty in D square. Now we are using a formula. This is a value for D. What is the value of a D square? So D square value will be 3.45 square. Now if I write a formula for the percentage uncertainty in the D square, it is the uncertainty in D divided by value recorded into 100. The percentage uncertainty in D square is this number, which is 0.057. Uncertainty we don't know. What about value recorded of a D square? So value recorded of a D square will not be 3.45, it will be 3.45 square. That's why we put 3.45 square into 100. And then we worked out the uncertainty of D square. Show that the uncertainty in area is about 0.05. How we can work out? We already worked out the uncertainty in D. This is our formula. Okay. Our formula D square plus small d square plus D into D. And their uncertainties are already given. We need the uncertainty in A. So how A is calculated in the question? So for A, what we need like we have we have the value for D square, we have capital D square, small d square, and a product of a D and small d. So in this case, if we want to determine the uncertainty, we don't have group of data. So what we need when we worked out the value for D square, what was a D square? 3.45 square is what? 3.45 multiplied by 3. Is like 11.90. So this is 11.90 and with the uncertainty of how much? 0.07. That is there. So what we will do for this area, if I substitute these values, I need the minimum value of area from this set of result. Yeah, 0.069, which is rounded off to 0.07. And I need the maximum value. So what I will do, I will substitute their minimum values, because when A will be like, I need the minimum value of A. How I'll determine the minimum value of A? I will substitute the minimum values of all of them. And then I will substitute the maximum value of A. Okay. So what is how to get the minimum value when D, capital D, small d, and the product of D, these are small? Like the minimum value, I'll get a minimum value of A. So it will be pi over 12. Pi over 12. What is the minimum value of a D square if I subtract 0.07 or 0.069, let's say? What is the minimum value? So it will be 11 point, like this will be 11.83. What is the minimum value of a D square if I subtract? So it will be 9.42. And what is the minimum value of D into D? If it will be as it is written here, 10.56 minus 0.07. So it will be 10.49. Sorry, it's the minimum I have to take. This will be 9.3 and this will be 10.49. This will give us the minimum value of A. And how I'll get a maximum value of A? Pi by 2. This is 11.97. This will be 9.42 because I know their uncertainties. And this is 10.63. This will be the maximum value of A. So after getting a maximum and the minimum, I need the uncertainty A in A. Minimum is 8.278 and the maximum is 8.383. Okay. So I got the minimum value and the maximum values. What I have to do, I have to just take the uncertainty. If I have the two values, what is the formula for uncertainty? It's a maximum minus minimum divided by 2. So uncertainty will be maximum value minus minimum value divided by 2. That will give us the uncertainty in A, which is how much? 0.053. Okay. Is it clear? This one? Then part C, deduce whether whether the rubber band and a rubber bung could be made of same material. This is again a very common question, a repeated question in exam. How to know, like example, whether they are made up of same material or other material. So you compare percentage uncertainty with a percentage difference. Okay. The density is 1.51 and the percentage uncertainty is 4.3. Um, so I can identify the maximum and the minimum value of, and then I'll compare the range overlapping. Like this is 4.3%. So either it will be plus 4.3% or minus 4.3%. And either this will be plus 1.3%, like higher. I will find 4.3% of this. So 4.3 times 1.15 divided by 100. What is the answer here? 4.3% of this 1.15. Yeah, 0.05 or 0.049. So 0.05 is there. So means what are the limits? Upper and the lower limit, like either it can be more than this, so it might be 1.20, and it might be lower than this, so it will be 1.1. And what about this one, 1.52? Like we'll work out the 1.2% of 1.52 divided by 100. What is the percentage? What is the number here? 0.018. So 0.018. So either it can be 0.018 more. So if I add 0.018, like 1.53, I think, and it will be subtracted. So the limit does not overlap. Like a rubber band and the rubber bung limit of a density does not overlap. Yeah, we just checked whether they're overlap. If they're not overlapping, like one of the value is like this range is different from this range. So it means they are not made up of same material, as there is no overlapping of their densities. So this was paper 6, unit 6 of 50 marks. Duration for this exam is 1 hour and 20 minutes.